but everything else needs to be put away. The formulas that I told you I would provide for you are printed on the quiz, so you didn't have anything else out. Okay, so pretty much the whole front half, or the first half of the front page, are the formulas. So law of sines, one of the area formulas in 3 different ways, law of cosines in 6 different ways, and Heron's formula. So question 1 wants to know when to use each of those. Those are 2 points apiece. Questions 2, 3, 4 are asking you to find some sides or some angles. So you need to put some thought into whether you should be using law of sines or law of cosines, whatever makes the most sense. So please be careful that you actually do use the formula correctly. Just because the formulas are provided for you, with my 8A classes, some people did lose a few points simply because they just didn't copy it down right when they used it. So of course there would be partial credit, but still I'd hate for you to lose points over that, but it does happen. I will also note that even though you should be in the habit of showing your work anyway, questions 2, 3, 4, 5, and 6 specifically ask to see the formulas with the numbers plugged in, and some of the points are assigned to that. So even if you feel comfortable enough with this topic that you could go straight to your calculator and straight to your answer, at best you could get half credit with that. You need to show what you're putting in the calculator at the very least. So all of that is in the directions, but just pointing it out to you. In the end, this makes up 30 points, which is not going to be very much, but for right now, it will be the only major grade you have in gradebook, so I certainly suggest that you guys check your work, make sure your numbers make sense. Make sure you read the directions. I think it asks you to label your answers on one of them, and so one of the points comes from that, so just double check the directions. Finally, you can take however long you need to, but we will start looking at the first little piece of what a limit is and how to do that. So when you guys come up here to pick up your phones, please grab these 3 handouts, and we'll talk about them once everybody is finished. Where your new seat is. Okay. So you can be right. Good. So they're quizzing today. You can use this time to get caught up, I guess. That might be the best. But do you know what you need to do? Okay, so the handouts that you missed are over there. If you haven't printed them out yet. And you'll need to make sure you find those class videos so that you can get all the information you need.
See if I can pencil it.
Yep, you can have one of those.
Can I get an extra sheet of paper?
Sure.
Thank you.
Thank you.
So this one, lining up with the answers. Or the special message.
Right here. This looks like you did 7 squared.
Oh, I did 15 squared.
Yeah, instead of 13 squared. Thank you.
sheet of paper.
Just need to staple it when he turns it in. Where's that little stapler?
Okay, after you guys turned in the quiz, there was the 3 handouts I wanted you to pick up. So if you forgot to grab your phone or forgot to get those handouts, please go and get them. 2 of them together will make up 62. That's the one I'm going to look at with you. And then 1 page is the start of 63, which I'm going to ask you to try between, it's very quick, but ask you to try between now and tomorrow, because I will see you guys again tomorrow since it is a B week. So unlike law of sines and law of cosines, where we barely spend any time at all, because really the only thing we're aiming for there is hoping that you can get 1 more ACT question correct. Limits, we will be spending several weeks on, and there's a lot of reasons for that. One is it gives you a taste of what calculus is like. 2, regardless of when you take calculus, if you ever do take calculus, whether it's next year or 5 years from now or 20 years from now, all calculus classes start with limits, so this will make that transition into that course a little bit easier. And what you'll see, not so much today, but most of the days that we're doing this stuff, the calculus concepts and steps are actually pretty easy. What can be difficult is the algebra behind it. So it's not that it's different algebra than you've seen. It's just, you know, one question will be some log property that you may not remember, and then the next question might be a complex fraction that you don't remember how to simplify, and then the next question might be a trig identity that you've forgotten about. So it just really piles up in calculus. So we do this to try to make it a little bit easier for you. So this first handout, this one is part of 62, this one. So from this, I would like you to know how to find what a limit is and how to find a limit from a graph, which admittedly is not very often. We probably wouldn't put more than 1 or 2 of these on your test, but even the AP calculus exam would have 1 of these questions probably. So when we do limits, there's actually 3 ways to do them. So you do need to write this down at the top of your page. Okay, so limit of which function we're talking about. So f of x, g of x, h of x, not usually an issue unless you've got multiple ones in front of you. And then as x approaches, and then this is going to be some number. So I'm just going to pick the number 3 just for something. Now sometimes there's going to be a little minus sign up here. Looks like a little exponent of a negative. You need to know this means from the left side of 3. Sometimes there's a plus, which is when we would want to be looking from the right side. And if there's not a plus or a minus, it has to come from both the left and right side. It's got to be the same from both the left and the right. Question. So all a limit really is it's asking what y value is that function approaching as x gets close to this. Not what is the y value. That would be asking for a point. This is asking what y value is it approaching. So sometimes we just look from the left. Sometimes we just look from the right, and then if it doesn't have it, we have to make sure that it's coming from the left and the right to get the same value. Okay, so let's look at some examples and show you how I would go about working these. Okay, so most of them on this handout are just both, but mentally what I would be doing here is if this doesn't have a plus or minus here, I know mentally I need to think about what is the limit from the left of 3, find that as an answer. What is the limit from the right of 3, get an answer. And if these two are the same thing, then that's going to be the answer to the question. And if those two are not the same thing, then this limit does not work. It does not exist. So we've got our graph up here. As x approaches 3 from the left, so from the left means you're taking a value smaller than 3, and you're inching your way closer to 3. So as x gets closer to 3, it gets closer to a y value of -4. So the limit from the left side would be -4. From the right side, you should pick an x value slightly bigger than 3 and inch your way closer to x equals 3. And so from the right side, it's approaching a y value of -4. And if it's approaching the same thing from the left and from the right, both, then that's how you would answer it if it doesn't have a plus or minus. Now, usually the first and most common trap that students fall into is, again, this has nothing to do with points. Notice this question, x equals 3 doesn't even exist. It's a hole. Limits could care less what's actually happening at x equals 3. You could completely not even see this part of the graph, and you can still just do a limit. What's the y value it's approaching from the left, from the right, and if they're the same, then that is the overall limit. So, not too bad, but it does take some practice. So, the next one down here, number 2, the limit as x approaches 5. So, I'm going to think about what's the y value it's approaching from the left. What's the y value that it's approaching from the right? And since this doesn't designate left or right, it's got to be both. So since those are both -2, the answer to that would be -2. Again, notice that point doesn't even exist, but it doesn't matter because limits don't care what's happening at that x value. They just care what it's approaching for those x values. Okay, question 3. The limit as x approaches 0. So I need to think about the y value it approaches on the left. Looks to be getting closer to 2. Think about the y value it's approaching from the right. Looks to be getting closer to a y value of 2. And since these are the same, that's the answer to your question. Now notice, not only does x equals 0 not exist here, it does exist way down here, but I didn't even have to consider that. It has nothing to do with limits. So don't let the x equals 0 value or lack of a value mess you up. All you care is about what y value is it getting closer to from the left, from the right. If they're the same, then that's what the limit is. Okay, so question 4, as x approaches -1, what does that look like it's approaching from the left side? I agree. It's getting closer to a y value of -3. Same thing from the right. Then, oops. I don't know why I wrote -4. Then that is your answer. Once you practice these and you know what you need to be looking for, these are honestly 5-second questions. Okay, I think on the next page for you, so sometimes we could do the same thing with a table, which I guess is a little bit harder because it's harder to visualize, but you should be thinking of exactly the same thing. If you want to know the limit as x approaches -2, you should be thinking about what it approaches from the left side. So as x gets closer to -2, it looks like the y values are getting closer to 8 probably. But you also have to test from the right side. Or I'm sorry, that is the right side. This would be the left side. So as x gets closer to -2 from the left side, the y values are getting closer to 8. And if it approaches 8 on the left and 8 on the right, then that limit is 8. That's all a limit means, is what y value is it approaching. Not what y value is it equal to, but what y value is it approaching. Now again, notice this question says reasonable estimate, because we don't really know. I mean, something crazy could happen between these two values. Probably not, but it looks like they're going to 8. Okay, I would like you to try 2 of these before I discuss them together. I'd like you to look at the table and try number 6. It is a little harder to come by table questions, so I do need you to practice that. And number 7, I'd like to see if you can get that before I tell you. See if you can catch. I verbalized it, but we had not seen it in a previous question. So try 6 and 7 just to see what you come up with. Okay, so on the table, it looks like from the left, I know this is from the left because the x values are less than 1. You think about a number line. It looks like the y value gets closer to maybe -6. And from the right side of, as x approaches 1, looks like the y values get closer and closer to -6. So the answer to question 6 was -6. Just a different way to try to compute the same thing. All right, we okay with that one? Okay, and then, so you shouldn't have done anything different on number 7 than I did on all the other graph questions, except this is the first one that does not exist. As x approaches 4 from the left, it looks like it's getting closer to a y value of 3, but from the right, it's getting closer to a y value of 6. I don't care that there's a point down here and not a point up here. I have zero interest in what's happening at x equals 4. I can ignore all that. So if the question was, what is the limit as x approaches 4 from the left, we would get an answer. If the question was, what is the limit as x approaches 4 from the right, we could get an answer. But if these two are not the same, then this one can't have an answer because it has to be the same value from both the left and the right. So on this one, it doesn't work, which in calculus we usually just say does not exist, or D and E if you don't want to write out does not exist. And that's it. If it's not the same from the left and the right, the limit does not exist. The left limit exists, the right limit exists, but the limit both can't, because you can't have two answers. It's got to be approaching the same value. Now, unfortunately, I don't remember when I made up this worksheet, but I did not scramble these questions up very well, so I need to probably scramble them up for next year. But let's go ahead and look at the other ones, and then I'd like you to try some of these questions on the next page. So the limit as x approaches 0. From the left, it looks like it gets closer to 5, but from the right, it gets closer to -5. If those are not the same thing, then the limit does not exist. No more thought needs to go into it. It's really that straightforward. Number 9, the limit as x approaches -4 from the left looks to be getting closer to -3. From the right, it appears to be getting closer to 2, but those are not the same value, so the limit for both doesn't exist. Okay, and then another one for the same reason, and then I do want you to try the next one. But as x approaches -5, so this is the part of the graph I'm interested in. I'm only interested in a little bit left of -5 and a little bit right of -5. But from the left, it gets closer to a y value of 6. From the right, it gets closer to a y value of -4. But if it wants the both, then they better be the same value. 6 and -4 are two different things, so you can't say that that has a limit. And then the last one, it's just kind of a twist on the question. Instead of finding the limit, it wants you to think about what x value could you approach to get a limit of 3. So you're actually trying to put in a number right here. And there's more than one correct answer here, but I do want you to look at your graph and give it a shot. See if you can find at least one of them. Okay, so what is one x value that you could approach to get a limit of 3? Yeah. X equals, as x approaches 2, I agree. Because as x gets closer to 3 from the left and the right, the y values are both getting closer to 3. So that would be fine. The other two, you do have to estimate a little bit, but right about here, I don't know, about 4.5 roughly. 4.5 also has a limit of 3. Because the limit is talking about the y value, and then maybe one more answer over here at about -8.5. So 2 is probably going to be the more common answer because the other two you had to estimate. But as x approaches any of those numbers, the limit would be 3 because it approaches 3 from both the left and the right. Okay, so unfortunately, most of the stuff we do with limits, we don't have a graph, and so that's a lot of what we will talk about tomorrow. But your third piece of paper that you guys got should look like this. And so on this one, this left graph is f of x, this right graph is g of x. Some of these questions are just asking for the left limit, some are asking for the right limit, and some are asking for both, like we did on the other page. So I would like you to try, you can see how quick these questions are, but I would like you to try all 18 of these before class tomorrow, so that way we can start off class by checking those and seeing if there's some misconception that you guys have, and we can move forward. So go ahead and try those, come up with an answer, we'll check them next class, and if something's off, we'll worry about it tomorrow. First question. Okay, so number one, you should be looking at the left graph because it's f of x, and you're approaching 3, but just from the left. So what y value is that getting closer to? So that's the answer to that. Because that one doesn't need both, it just wants from the left. And really, on this top half, these questions kind of go together, because then it asks you the same thing but from the right. And then since these are the same, that's the same. So 1 and 2, you've got to think about 1 and 2 to be able to answer a question like number 3 anyway. It's just that with the first 9, I made you answer those, whereas after that it's a little more scrambled up.